Okay, Wildcats, today we're going to journal page 20, Solving Systems of Linear and Quadratic Equations, Part 2. Solving systems of linear quadratic equations by substitution. Step 1. Solve one of the equations for either x or y. Step 2. Substitute the equation from step 1 into the second equation. Step 3. Solve the second equation. Step 4. Use the found variable in step 3 to find the other variable. Solving systems of linear and quadratic equations cannot be solved using the elimination method. All right, if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. Okay, solving systems of linear and quadratic equations, part 2. Solve the systems of linear and quadratic equations by substitution. Now you should recognize these equations. These are the same systems from journal page 19. I'm going to use the same one so I can show you how we solved them by graphing on the last journal page, and now we're going to solve them by substitution in this page, okay? All right, so let me double check my notes to make sure I say the steps right. So step 1, solve one of the equations for either x or y. Well, this equation is already solved for y, okay? So now we move to step 2. Substitute the equation from step 1 into the second equation. So we're going to plug y equals 2 into here, okay? So then y is 2, we plug in 2 for y, so 2 equals x plus 1 squared plus 2. Okay? Now step 3, solve the second equation. So now to solve, we're going to subtract 2 from both sides. 2 minus 2 is 0, so 0 equals x plus 1 squared. And then 2 minus 2 is 0, so that's gone. Now what we need to do is we need to take the square root of both sides. Well, remember, we can do that because of equality. What we do to one side, we do to the other. Okay? The square root of 0 is 0. When you take the square root of squared, that goes away, and you're left with x plus 1. And then the last step, we're going to subtract 1 from both sides. So negative 1 equals x. Okay? Now we know the y value is 2, so our point of intersection is negative 1 comma 2. Okay? If you would, update example number 1. All right, example 2. Okay? So first step is solve one of the equations for either x or y. We notice that either one solve for y. Since they're both equal to y, we can say they're both equal to each other. Okay? So we can say that negative 1x minus 3 is equivalent to x squared plus 2x minus 3. Okay? All right? Now we're going to see step 2, substitute. We did that. Step 3, solve the second equation. So now we're going to solve this. So we're going to add 3 to both sides. Okay? So then you get negative 1x equals 1x squared plus 2x. Okay? Now we're going to add 1x to both sides. So then you get 0 equals x squared plus 3x. Now to solve this, we're going to factor out an x from both. Notice this has 2 x's, this has 1, so we can take 1 from each. So we do that, we get 0 equals x times x plus 3. And we can do that. Let me show you, if we do that in reverse, if we go back and multiply this, well, that 0 equals x times x is x squared, and x times 3 is plus 3x. So you can see that x squared plus 3x is equivalent to x times x plus 3. Okay? All right. Now we set each of these equal to 0. So x equal to 0. x plus 3 equal to 0. Well, x equals 0, that's done. Subtract 3 from both sides, so x equals negative 3. Now we need to find the y value because we need to find the point of intersection. So now we're going to plug in 0 into the first equation and find the y, and plug in the negative 3 into the first equation and find the y. Okay, so when x is 0, y equals negative 1 times 0 minus 3. Okay, so then that's y equals negative 3. So your point of intersection is 0, negative 3. Okay. All right. Now for when x is negative 3. Okay. So then y equals negative 1 times negative 3 minus 3. Well, then that's y equals negative 1 times negative 3 is a positive 3 minus 3. So y equals 0. So your point of intersection is negative 3, 0. Okay, so go ahead and finish up example 2. All right, now let's take a look at example 3. Now example 3, okay? So we're going to set this negative 6 divided by 5, x plus 9 equals negative 1 times x minus 4 squared plus 2. And the reason being is if they're both equal to y, they're both equal to each other. Okay? Now to solve, we're going to multiply both sides by 5. So 5 times negative 6 is negative 30 divided by 5, x plus 9 times 5 is 45 equals 5 times negative 1 is negative 5 times x minus 4 squared plus 5 times 2 is 10. This becomes negative 6x plus 45 equals negative 5 times x minus 4 squared plus 10. If you get to a point where you can't solve it algebraically, you're going to go back to how we did in our journal page 19. We're going to solve graphically. Okay, so let's do that now. Okay, so we're going to go, let me get Desmos open. So we're going to graph y equals negative parentheses x minus 4 squared plus 2. Okay. And then we're going to graph y equals negative 6 divided by 5 x. Make sure the x is not in the denominator. You need to click to the right, x here, and then plus 9. You see here that they do not intersect, so there's no solution. Let me see if I can get back to my, yep. So this one has no solution. Okay. Now, a little note, systems of linear and quadratic equations cannot be solved using the elimination method. Okay. And I think, all right, mark that. Let me mark that in big. The word cannot. Okay. So if you would, finish up your examples and have a wonderful Wildcat day.